Alright, so this video is going to be the Mod 4 Topic 1 kind of quadratics review. So just a review of the different types of quadratic equations. The first one is our standard form equation, so letter D. Because remember, standard form is kind of what we build the quadratic formula off of, where we get our A, B, and C. Number 2 is our factored form. Remember, factored form we always do with two sets of parentheses. We can get our x-intercepts very easily this way, or our axis of symmetry. The next one here is a vertex form. Okay, remember we take h and k, and that's my vertex of my parabola or my quadratic, and you always flip that h value. And then the last one here is the quadratic formula that we use from this, our a, b's, and c's. That also finds me my x-intercepts. Okay, so if I'm graphing here, if you need to, you can use a graphing calculator. Otherwise, you can find the hk pretty quickly here by flipping this guy when you take him out, and then keeping the other one normal. That's my vertex. I'm going to go -1, 1, 2, 3. Again, you can use your graphing calculator to do this as well. Make sure you are getting I probably want at least 5 points here to get the full shape of it. The next step then, if you're using the shortcut, your normal shortcut for quadratics are 1, 3, 5 up. In this case, because of that negative that sits there, I'm actually going to do 1, 3, 5 down. So I'm going to go right 1, down 1, right 1, down 1, 2, 3, and then right 1, down 1, 2, 3, 4, 1, 2, 3, 4, 5. Okay, and then we got the mirror image. But again, if you are using your graphing calculator, you should get the exact same thing. Okay, if we're talking about kind of what's happening in this equation here, the negative is a reflect across the x-axis. That's why it's facing down, opening down. This would be my left one, and then my up 3. Okay, the next one here, if I'm getting my vertex, we flip the guy on the inside, keep the other one normal. So 4, -7. So 1, 2, 3, 4, 1, 2, 3, 4, 5, 6, 7. Okay, our normal 1, 3, 5 up is now going to be multiplied by 2. So 2, 6, 10 up. Or use your graphing calculator. So right 1 up, 1, 2, right 1 up, 1, 2, 3, 4, 5, 6. And then we have the mirror image across. Okay, so remember that 2 is going to stretch it by 2. Then we have a right 4 and a down 7. Okay, so we're writing some equations this time. So it says find a way to change the equation to make the y equals x squared parabola vertically compress, open down, move 5 units up and 2 units left. Okay, so I'm going to do the compress and opens down first. So to compress it, we need a number between 0 and 1. And then to make it open down, we need a negative. We need a sad parabola. So negative, I'm going to say 1/3. And then my inside is my left and right. So if I'm trying to go left here, I'm going to do x plus 2. Don't forget my square to say it's a parabola. And then I am going 5 units up. So up and down is on the outside. Now we are stretching. So any number bigger than 1, so let's say 3, we have a reflection across the y-axis, 7 units down and 5 units right. So if I'm doing the reflection across the y, we throw the negative on the x, and then we are doing 7 units down, 5 units right. So 5 units right, 7 units down. What does it mean to find the roots of a quadratic function? Remember, roots are the same thing as zeros or x-intercepts. So we're finding where it's intercepting the x-axis. Okay, solve the following quadratic equations by factoring. Okay, this one we're actually not going to factor. I'm going to use the square root property because it'll be a little bit easier. I can show you kind of the process of the solving by factoring in a little bit, but it'll be easier to use the square root property for that one. Okay, when we solve, that means we're actually finding the x-intercepts. Okay, so in this one, if I set it up here, I have my a times c and my b. So a times c is 6, my b is 5, and my front guy goes here and here. Then it's what multiplies to the top, adds to the bottom. Okay, so if I'm doing this, 3 and 2 multiply to 6 and add to 5. So I'm going to have 2x plus 3, and this one I can simplify. So if I divide them both by 2, I get x and 1. So x plus 1. Okay, but if we're solving, I need the actual x-intercept. So this one, if I set it equal to 0, and this one, here's my ZPP property. And if I solve them, this one I subtract 1, so -1. This one I subtract 3 and divide by 2. So, ran out of space. X is equal to -3/2, which should be where it crosses on the x-axis. Okay, so my next one, if I wanted to use factoring for this guy here, what I would have to do is I'd have to write this guy out twice. So I'd have to write x plus 2 times x plus 2, and then I would distribute, so x squared plus 2x plus 2x plus 4. I still got that minus 9 sitting out there, and I still have this 3 in the front. Okay, then I could send my 3 in if I wanted to, or I could combine like terms. It's a very long process, because once you send it in, then you can factor. If we wanted to just use square root property, if I set it equal to 0 here, first thing I work outside in. So I'm going to add the 9. Divide by 3, because right now it's being multiplied, so 3 is equal to x plus 2 squared. Now I can square root, which gives me a plus or minus. Remember, anytime you solve and you square root, you have the positive and negative, and then subtract 2. I like to stick them out in the front, so I'm going to say negative 2 plus or minus the square root of. All right, so my next set here, probably want to use square root property again, so I'm going to subtract 7. Get negative 7 is equal to x plus 4 squared. Opposite of squaring is square rooting. Okay, if you're my IM 11, you know how to square root negatives now. So first, if I wrote it this way, if you're 11a, this would be no real answer. Okay, because it's imaginary and we haven't gotten that far. So my imaginary answer here, remember to get the negative out, we put an I. And then I can keep solving. So I'm going to subtract that 4 and get negative 4 plus or minus I square root 7 is equal to x. Okay, next one here. We're going to try to factor because I've got x squared x in a number. So a times c is up here, b is down here, so negative 96, negative 4, and then front guy, front guy. So multiplies to negative 96, adds to negative 4. So I got negative 12 and 8. So x minus 12, x plus 8 is equal to 0. So my x-intercepts, I would add 12 and subtract 8. Okay, next one here. I get my snowflake, so 36, 12, x and x, so 6 and 6. So x plus 6, I could write it out twice, or I can write it with a squared because I'm lazy. So I really only need one of them because it's the same thing written twice. So negative 6. Okay, next one here. If I wanted a snowflake, a times c would be negative 9. Your b is not there, so 0 and x. So it would be 3 and negative 3. Or you could use the square root property. You could add 9, square root. Your answers would be 3 and negative 3 still. All right, a times c in this one, so 3 times negative 2 is negative 6. Remember, that has a 1, it's not a 0, and then 3x, 3x. So multiplies to negative 6, adds to 1 is 3 and negative 2. This one we can simplify to x plus 1, so divide them both by 3. So x plus 1 and 3x minus 2. So if I solve this, I would get negative 1. This one, if I actually do it, I would add 2. Divide by 3. All right, next one. If I wanted to go into my snowflake, the a times c is actually 0. This is 1, 5x and 5x. Actually, the easiest way to do this one is to see that there's a GCF, which is an x. So if I take that x out, I'm now left with this. So this one is x is equal to 0, no solving. This one, if I wanted to solve, I would subtract 1, divide by 5. All right, now we're using the quadratic formula. So remember, the first thing I like to check is my b squared minus 4ac, my discriminant, because my discriminant tells me how many real roots there are. If there are no real roots, then I don't have to do anything, okay? Remember, if it's bigger than 1, there's going to be 2 answers. If it is equal to 0, or if it's bigger than 0, 2 real answers. If it's equal to 0, 1 real answer. And if it's negative, you can't square root negatives unless you're trying to get imaginaries, but that would mean no real answers, okay? Your whole quadratic formula, negative b plus or minus the square root of that discriminant, so b squared minus 4ac, all over 2a. Okay, so first I have a, b, c. So my discriminant is b squared minus 4 times a times c, which I got 28. So I'm going to have two real answers. So x is equal to opposite b. Opposite b plus or minus the square root of that 28 all over 2 times a, which is negative 1. Okay, so if I do that 2 times negative 1, I get negative 2. And that level 4 bump up is taking that square root of 28 and breaking him down. So I got 7 and 4, 2 and 2. So 2, 2, 7. Pair him up, escape die. So he is going to become 2 square root 7. So I'm going to erase him in here. I'm going to put 2 square root 7. And then it keeps going. My trio is here. I can divide them all by 2 to keep simplifying. So I'm going to get x is equal to 1 plus or minus 1 square root 7 all over negative 1. Okay? If you are needing to get the decimal, remember, if you're trying to type this in, you do 1 plus the square root and divide by negative 1. You type in the top first and then press enter, divide by bottom. Okay? Then you do the bottom. You type in the top first and then divide by the bottom if you're trying to get the answer. But always do the top, press enter, then divide by the bottom. Okay? My next one here, so I've got a, b, c. So b squared minus 4 times a times c. Which is 44. So x is equal to opposite b, so negative 8. Plus or minus the square root of 44 all over 2 times a. So that gives me 2 times a down here. I'm going to put negative 10. And then here's your level 4 bump up, taking that square root of 44, breaking him down, seeing if that trio is present. So I'm going to do 4 and 11, 2 and 2. Pair them up, escape die. So 2 square root 11 is what I'm going to actually shove in here. Oops. Okay, and then my trio is present. So I'm going to divide them all, kind of like a GCF, divide them all by 2. So I've got negative 4, a 1, which I really don't need, and a negative 5. All right, getting into some graphing. So given the equation and graph of the parabola, find the following information. So equation in vertex form, the vertex. Okay, remember vertex is that change of direction. So it is this little guy right here. So it is 1, comma, 1, 2, 3, 4, 5, 6, 7, 8, 9. So 1, negative 9. Vertex form, remember, is y equals a times x minus h squared plus k, where it's literally got the vertex in it. The a comes from the original. So we don't really need the 1 there. I'm just going to show it to you being there just to show that the a was being used from here. Remember, whenever you go into the parentheses or out of the parentheses, you flip. So instead of a positive 1 h value, it is a negative 1 h value. And then the k or the y value stays normal. Okay, this little guy is opening up. He is a minimum at 1, negative 9. Those zeros are those x-intercepts. Okay, this one, my graph is kind of off a little bit. He should have been negative 2, 0, and 1, 2, 3, 4, 0. Otherwise, you can factor it or use quadratic formula to find them. Okay, axis of symmetry. It is the axis that is symmetrical off of this guy right here. Okay, you can either average those x-intercepts, or this one's a pretty one. It is the x value of your vertex slash minimum maximum. So it is an x equals line, and then I'm just going to follow that 1 value from before. Okay, your y-intercept, where it intercepts your y-axis. So that is 0, comma, negative 8. All right, domain is what it does on your x value. So it goes forever this way, and it goes forever this way. So this guy, remember, is all real numbers. My range, we read bottom to top. So if I literally go on my y-axis, the first y value I see when I go bottom to top is negative 9, and I'm going to bracket him. And then they keep going up this way, so it is going up to positive infinity. All right, the next one we got, the vertex is at negative 1, 9. Remember that vertex is that point right there. Okay, we are opening down, which means we have a maximum at that vertex. So I'm going to get y equals the a value from the original this time is -1. When I put my x value in with that x, I flip them, so +1, and then I keep the k value normal, so +9. Axis of symmetry is that exact same x value. It's crossing my x-axis, so my zeros are 2, 0, -4, 0. Okay, crosses my y-axis right here, so 5, 6, 7, 8, so 0, 8. Domain is always all real numbers for these guys. Reading bottom to top, it goes forever this way, and it stops at 9. So from -infinity, and it tops out at 9. Remember, you always go smallest to biggest or most negative to positive when you're writing the domain and range. All right, the next one. Sketch a clear graph of a quadratic equation with the discriminant is positive. So if my discriminant is positive, an example, square root of 64, we have a positive and -8, which means he intercepts twice. We have 2 real answers. If it is negative, square root of -2 gives me no real answers. So he's either floating above it or below it because I don't have x-intercepts then. Okay, if it's equal to 0, if I take the square root of 0, there is not a plus or minus 0, so it is literally touching my x-axis 1 time, 1 real. This one was no real x-intercepts. Okay, then we talked about the first and second differences to determine whether it was linear and quadratic. Remember, if the first difference is all the same, it's linear, and that's going to actually represent your slope. And then if the second differences are all the same, then it's going to be our quadratic. Okay, so first off, you need to type this in your y equals, and you need to look at your table to get your y values. Okay, so type in y equals 2x minus 1, and then press your second graph to look at your table. You should get -5, -3, -1, 1, 3, and 5. And then when we do our differences, we do bottom to top. So I am doing -3 minus -5. Okay, so that gives me 2. -1 minus -3, 2. 1 minus -1, 2. 3 minus 1, 2. 5 minus 3, 2. That just right there told me he's going to be linear because they're all the same. Okay, if I do it all again, you should get zeros across the board. For my next one, type in x squared plus 1. So clear out the other one, type it in, look at your table. Your table should say 5, 2, 1, 2, 5, 10. So 2 minus 5 is -3. 1 minus 2 is -1. 2 minus 1, 1. 5 minus 2, 3. 10 minus 5, 5. Okay, if I do it all again, boom, 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 it is going to be 2 for all of them, which told me quadratic. Okay, if you notice, this 2 here is also the slope. Should be the same for linear. Okay, so write the following quadratic equations giving the x-intercepts and find the axis of symmetry. Okay, if I'm giving you the x-intercepts, factored form is the best form because when we factor, we find x-intercepts. Okay, so if I remember, factored form is a times x minus whatever times x minus whatever. Okay, so in this situation, remember anytime you go in parentheses or out of parentheses, you flip. So I got y is equal to x plus 2 and x minus 5, and to make them open down, and you throw a negative there. Okay, to find the axis of symmetry. If you literally think this is at -2, 0, 1, 2, 3, 4, 5, 5, 0, how do I find the axis that makes them symmetrical? You add and divide by 2. So -2 plus 5, all divided by 2. To find that middle ground. Remember, axis of symmetry is always x equals. So x equals 3 over 2, or 1.5. So my next one here, y is equal to x minus 4, x, ooh, I don't really care how this one goes, but if we wanted to simplify him, he could just be an x, because x minus 0 is just x. Okay, so now finding the axis of symmetry, 4 plus 0 divided by 2 to get the middle grounds, so x equals 2. And you only care about adding the x values. Okay, now the next set, we are factoring, so back to the snowflakes again. So in this one, we already kind of did it in the original set here. Okay, so my a times c is negative 6, or negative 96. Negative 4, x and x. So negative 12 and 8. Oops. And this one we're not actually solving, we're just factoring. So x minus 12, x plus 8. Okay, this one we go into it. Negative 77, negative 4, x and x. So negative 11 and 7. So x minus 11, x plus 7, because remember it's multiplies to here, adds to here. All right, this one's an interesting one. So you can't actually do the snowflake for this one. This one is both perfect squares though. So what multiplies to get me 4? 2 and 2. What multiplies to get me x squared? X and x. Multiplies to get me y squared is y and y. And to make him a negative, I need one being positive, one being negative. So that one's kind of a tricky one because you have to realize that they are perfect squares. Okay, this one we go in 36, 12, x and x. So 6 and 6. So I could write it out twice, or I could write it with a squared. Okay, snowflake this up. Negative 9, there is no b, so 0, x and x, so 3 and negative 3. So x plus 3, x minus 3. 9, negative 6, x and x, so negative 3, negative 3, so x minus 3, I could write it out twice or write it with a squared. A times c, so 3 times negative 2 is negative 6. There is a 1 that sits there, he does exist, front guy, front guy. So 3 and negative 2, so my 3x minus 2 is good. My left side, if I divide by 3, I get 1x plus 1, so x plus 1, or 1x plus 1. Okay, this one. This one, it gets weird in the snowflake. If you want to try to do it, your a times c is 0. This is 1, 4x and 4x. Okay, otherwise there's a GCF you can take out in x. So this would become x squared divided by x. Remember, if you're bad at it, write it out and cancel. So 4x plus x divided by x is 1. Okay, a times c, so 2 times 2, we got 4. 5, front guy, so 4 and 1, so my 2x plus 1 is good. I'm going to divide this other side by 2, so he'll become a 1x, he'll become a 2, so x plus 2. Alright, this one is a perfect square, or you can go in, do your 4 times negative 49 and work negative 196 and 0. Do your 4x and 4x. So it would be 14, negative 14, and then you'd have to divide them both by 2. So he'd become a 2x and a 7, a 2x and a negative 7, or you can see that they're both perfect squares. Okay, so what multiplies to 4 is 2 and 2. Multiplies to 49 is 7 and 7. And we need the positive negative, or do the exact same thing but with the snowflake. Okay, so the next one is a perfect square again. So if I do 16 times negative 81, so if I want to do the snowflake, it's a pretty big number, 0, 16x, 16x. Okay, so the number for that is 36 and negative 36, and then simplify. Otherwise, the perfect square, the number that gets me to 16, the number that gets me to 81. Oops. Okay, so this one, a times c, so 9 times 4. B, front guy, so multiplies to 36 and adds to negative 15. Negative 3, negative 12. So if I divide by 3 for the left guy, he becomes a 3x and a negative 1, a 3x, and a negative 4. Okay, a times c is negative 36. 0, front guy, so 6 and negative 6. Multiply and add, so x plus 6, x minus 6. This is also another perfect square. Negative 5, 4, x and x, so negative 4, 5, negative 1. So x plus 5, x minus 1. Okay, this one has a GCF of 2x. So I'm going to stick that 2x outside. The 2 divided by 2 is 1. X squared divided by x. Remember, if you're bad at it, write it out the long way, cancel. So we're just going to get an x plus 6 divided by 2 is 3, and the x's cancel. Okay, this one is also a perfect square if you want to use the shortcut. Otherwise, a times c, b, front guy, so 2 and negative 2. Alright, now we're just distributing. So if I'm going to distribute, 2x times x is 2x squared, 2x times negative 7 is negative 14x, 3 times x is 3x, and 3 times negative 7 is negative 21. Go ahead and combine your center. Okay, 4x times 3x is 12x squared. 4x times 5 is 20x. Negative 2 times 3x is negative 6x. Negative 2 times 5, negative 10. And combine like terms. So plus 14x. Okay, remember when you're multiplying things, that's when the exponents change. When you're adding them, it doesn't become x squared. Okay, this one's a lot of rainbows. So x times x squared is x cubed. X times 3x is 3x squared. X times 5 is 5x. Now I do my negative 2, so negative 2 times x squared is negative 2x squared. Negative 2 times 3x is negative 6x, and negative 2 times 5 is negative 10. Make sure you're writing it in standard form, so I've got my cubes. Now if I combine my squares, and then if I combine my x's here, so negative 1x and negative 10. Okay, the next one, remember squareds we read out twice. So I'm going to write another x plus 4 here. So x times x is x squared. X times 4 is 4x. 4 times x is 4x. And 4 times 4 is 16. So that gets me x squared plus 8x plus 16. Alright, so I'm going to write that 3x minus 5 out twice. So we are going to distribute the 3x minus 5 first, and then the 4 will come. So the 4 is just going to chill out here. 3x times 3x is 9x squared. 3x times negative 5 is negative 15x. Negative 5 times 3x is negative 15x. Negative 5 times negative 5 is 25. And then I'm going to go ahead and simplify in there to make it a little bit smaller, so minus 30x. And then I send that weird little GCF in. So 36x squared minus 120x plus 100. So the GCF little guys, you just sit on the outside until the very end. All right, 3x times 5x, 15x squared. 3x times 5n is plus 15xn. Then my center guy here, so 5 times 5 is 25, and then I got an nx. And then 5n times 5n is 25n squared. So these are actually the same, even though the letters are written in a different order. So if I combine them, I get 40xn plus 25n squared. All right, combine like terms. If I got a plus sign, it doesn't do anything. If I distribute a positive 1, it does not change it at all. So pretend these don't exist, and we're just going to combine like terms. So my x squared guy doesn't have a buddy. Remember, exponents are not going to change. 2x plus x is 3x. Negative 7 plus negative 1 is negative 8. Okay, this one, distributing a negative 1 does change things. So he's going to become a negative 1x plus 3, and then I still have all this stuff in the front. So negative 4x squared doesn't have a buddy. 2x minus x is 1x. Negative 4 plus 3 is negative 1. Alright, distributing negative 1, so negative 1x squared minus 6. Bringing the rest of it down here because they don't have anything, so x to the 4th doesn't have a buddy. Then I write it in standard form, so my x squared, which I really don't need the 1 there, and then the negative 1 and negative 6 gives me negative 7. Okay, plus 1 doesn't do anything, so I'm just going to go into combining. My x cubed comes first, then I take my x squareds to get 2x squared. Then my x doesn't have a buddy. Negative 5 and 5 gives me 0. Okay, and the last couple ones here, we're simplifying the radicals, so my little radical jail here. So if I take 207, looks like 23 and 9 go into it. This gives me 3 and 3. So 3, 3, and 23. So pair them up, 1 escapes, 1 dies, so 3 root 23. Okay, and then if you're trying to find decimal, you can type in the original or type in this one, and you would get 14.4. Okay, 63 here. Let's see, 3 and I had 21, which is 7 and 3 then. So I've got 3, 3, 7. Pair them up, 1 escapes, 1 dies, so 3 root 7. And then his equivalent decimal would be 7.9. So you either type in 3 root 7 or you type in the original square root of 63 to get the decimal. Okay, 5 and 4, 2 and 2. So if I put them all in, 2, 2, 2, 5. Pair them up, 1 escapes, 1 dies. So 2 root 5, which is equivalent to 4.5.